Hi all, this video will provide you with a brief overview of the web version of the specification language named Cyclone. Unlike other languages, Cyclone can be used to give solutions to problems in the form of graphs. In this video I'll run through a few examples to help give you a simple understanding of the program's capabilities. So, as you can see, I have the web version of Cyclone open on my browser. Firstly, I'll show you how you can find the Hamiltonian path of a graph simply by using the tool. For those unfamiliar with this problem, we're given a graph, but we must find the path that reaches every single node exactly once. So in this case, we're going to use a directed graph. So in Cyclone, I have written, we have every single node. So we're starting on the node S0 and we're moving all the way down to S6. Next up, we have our edges of the graph and the direction they're heading in. So in this case, S0 can go to S1, S3, and S6. S1 can go to S2 and S3, and so on for every single possible path it can take. And at the very, very end, we have the goal that we want the programs to satisfy. So in this case, we have every node must be visited at most and at least once, and it can finish on any node as well once there's no repeats. Then at the very, very, very end, we have an option to generate a trace file, which will basically allow you to download a quick text file, which will show you the path that was taken. So we'll run it real quick. All right, so as we can see, we have our path found here. So it's going from S0 to S6, S3, 4, 5, 2, and 1. So again, it's reached every single node, but it hasn't backtracked on itself or it hasn't repeated anything. So if we download this trace file here and we pull it up from the side, this is what we're given. So again, it's showing the path that it took and how it reached it. So it went from S0 to S6, S3, 4, 5, and finally 2 and 1. So that's how you can find the Hamiltonian path using Cyclone. Cyclone can also be used to build simple models and find their potential solutions. So an example that I find particularly interesting is the one to solve the water jug problem from the film Die Hard. Again, for those unfamiliar with the problem, two characters from the film have been given a particularly tricky task in order to defuse a bomb. So, to defuse this bomb, they must place a jug with exactly 4 gallons of water onto a scale, but they've only been given a jug that can hold 3 gallons and a jug that can hold 5 gallons. So I'll open up this example down here. Perfect. So again, as I specified, we've written all of these rules that the program must follow. So we have written here, we have jug 1, which can hold a volume of 0 to 3 gallons, jug 2, which is 0 to 5 gallons, and then the amount that we can fill each one by. Then again, we have our starting state, so obviously both our jugs are empty and there's no water in any of them. And then we have the rules that the program must follow. So we can pour jug 2's water into jug 1, which will work out to this. We can do vice versa, so we can pour the 3 gallon jug into the 5 gallon jug. On top of that, we can also empty out jug 1, so our 3 gallon jug. We can empty out our 5 gallon jug. We can fill our 3 gallon jug from the top or to the top, and we can fill our 5 gallon jug to the top as well. So they're the only actions that this program can take in order to satisfy this. And again, the goal at the very end is jug 2, so our 5 gallon jug must have a value of 4. So again, as well, at the very, very end, if it's found the path, it will generate a trace file. So we run this, it's found our path. So we start by filling jug 2, empty jug 2 into jug 1, empty jug 1, pour jug 2 into jug 1, fill jug 2 once again, and then empty jug 2 into jug 1. So if we download our trace file, again, we can see each path or each step that it had taken. So let me get this up real quickly. All right, so here we have it. So again, here's our starting point where both are empty. We then fill jug 2, so our 5 gallon jug. We pour all of the contents from jug 2 into jug 1, which leaves us with a full 3 gallon jug and 2 gallons left in jug 2. Then we empty jug 1, leaving jug 2, our 5 gallon jug. We then fill jug 1 with the volume of jug 2, so that'll put 2 gallons into jug 1. Fill our 5 gallon jug once again, pour our remains into our 3-gallon jug, and then we're left with 4 gallons in our 5-gallon jug. Alright, so hopefully this short video has given you a brief overview of Cyclone and its capabilities. Thank you so much for listening.